Thank you very much. We're on the last module of Module 1, that is Module 1.3. We're going to look at application of one-dimensional heat transfer by conduction to spherical systems, multi-layer spherical systems. Then we'll look at illustrations and we'll conclude. Now, for spherical systems, the procedure is the same procedure as the heat flow through spherical composite bodies. So just like we did for cylindrical systems, the difference here is that the area of a sphere is 4 pi r squared. Remember, for cylinder, we had 2 pi r L, but here we're having 4 pi r squared. So we substitute for the area, and then we separate variables and integrate, and we have the resistance for the sphere, which is different from the resistance for the cylinder. Now, for multi-layer, we are seeing the same thing again. Minus 4 pi delta T divided by the resistance, depending on how many composite bodies that we have. And we did the same treatment again to get the mean, the geometrical mean of the inner and outer surface area. So we'll put up an illustration. This is a spherical storage tank, internal diameter, thickness, all that. You are asked to choose which of the materials you use. So the choice will depend on the cost of each material. So we try to calculate for the concrete insulation. The calculation is there. If you follow it judiciously, you will see that. And we'll have 380 million. Then we did for 85% magnesium insulation, and we're having 195 million. Therefore, magnesia is cheaper and better. So when you go through that, you find out when you get the thickness, you get the mass, and then you get the mass, you are given the cost of per kg, then you get the total cost of the quantity that was calculated. And that will help us to choose between any two materials that are available to us. Thank you very much. It's a very short video because it was dealing with something we have done before, just applying to spherical systems. And that's the end of Module 1. So next time we'll continue the class with Module 2, with Module 2.1. Thank you very much for listening.